Hello, fifth graders, and welcome to your math lesson for today. For today, you will need your 5B textbook, your 5B workbook, math resource binder, paper, and pencil. So go ahead and get those things, and we're going to get into it. All right, fifth graders, today's warm-up is actually building off of what our skills were yesterday. So we have a chart here, and this is, again, something you would see on a test where you're supposed to complete the chart. So if you're given a fraction, what would be the decimal and percent form of these? If you're given a decimal, what would be the fraction and percent form of these? And eventually, you might be given a percent too and try to work back. So remember what we practiced in our lesson yesterday. So go ahead and pause, give this a try, and come on back. Okay, so if we're starting with 1/4, remember fractions are division, and this is actually a problem that we did yesterday. So maybe you remembered even. But 4 goes into 10 2 times. 2 times 4 is 8 with a remainder of 2. We add a 0, bring it down. 4 goes into 5. 5 goes into 4. Excuse me. What am I talking about? 4 goes into 20 5 times with a remainder of 0. So 1/4 as a decimal is 25 hundredths, which we figured out from our division. And then remember, 1, 2, we go 2 spaces over to make our percent, so 25%, okay? This, I would have personally, well, either way, right? If we know that we're making a decimal into a percent, we'd say 1, 2. Remember, we have to add that 0 in order to make that work, and we end up with 80%. And then I think about if I'm going to make it a fraction, this is 8/10, which is 8/10. Then we just have to check, like we always need to check, can we simplify? Which we can. These are both divisible by 2. So we end up with 4/5. How'd we do, fifth graders? It's kind of the first time we've done this, so it's a little bit of a new skill. But hopefully you found some success with it. But again, if this is giving you some trouble, come to office hours. We'd love to talk it through with you, okay? All right. So we're getting into our pie charts in our textbooks today. So yesterday we introduced pie charts. We talked about some rules, right? We talked about how all of a pie chart, if it's fractions, the whole thing is going to add up to 1. We talked about how all of a pie chart with percentages is going to add up to 100%. Remember, we talked about those straight lines would make up half of the pie chart. If there's a portion that has a straight line, that's a half of the pie chart, or 50%. If there is a right angle, that's going to be 1/4 of the pie chart, or 25%. Okay, so today in our textbook, we're going to be getting into page 131. Again, our objective is really kind of working with pie charts, just really getting familiar with how it's going to look, how it's going to work, and then we're going to keep building on these skills with each day. Okay, so 131 is where we're starting in our textbooks. We'll do some practice and then we'll get into the other parts of our lesson. Okay, so with that, I'm going to flip you around and we'll take a look. Okay, so the table shows the number of t-shirts of different sizes sold in a shop on a certain day. So there were 9 smalls sold, 18 mediums, 6 larges, and 3 extra larges. So we say altogether there's 36 shirts, which they're telling us, but we could figure out by adding these together, right? If we were to add all of these digits together, we would get 36, okay? Okay, we're also saying that 1/4 of the t-shirts are a size small, which we know by creating that fraction over a whole, right? If this is our total, 36, this kind of should bring us back to some of our line graph and bar graph histograms that we were doing. If 36 is the total, and this actually shows it over here, and 9 are small, we make our fraction 9/36, which when simplified becomes 1/4. So now we're being asked what fraction of the t-shirts are medium. So let's work on this together. So remember, if we're creating fractions, that denominator should always be the total. If we're asking, well, what fraction of something, we want to make sure our denominator is the total amount, which we've already worked out. What is the total amount? And by we, I should say they've already worked out. Yeah, 36 altogether. How many of them are medium? We look to our table. 18 of them are medium. And so now we have to simplify. Our greatest common factor here is going to be, it's actually going to be 18, but you could go along your way, right? My first instinct was, oh, let's do 9. So 18 divided by 9 is 2. 36 divided by 9 is 4. But then you're like, those are both even. We can go further. So 1/2. Okay, and maybe you would have thought, oh, I can do 3, I can do 2, and then kind of inch your way along, as long as you get to this end point where we know what all the final simplification is. So what fraction of the t-shirts are medium? 1/2. What fraction of the t-shirts are large? I'd like you to pause and try this one on your own based on what we just did here. What fraction of the t-shirts are large? And then come on back and see how you did. So again, our denominator should be 36. That's the total number of t-shirts. Our numerator then is going to be 6. And now we simplify. These are both divisible by 6. We're going to divide by 6 over 6 to get 1/6. So 1/6 of the t-shirts are large. How'd you do? Why don't you give it another try? Again, what fraction of the t-shirts are extra large? So follow that same process. You're going to pause and then come on back. So again, our denominator is 36. Our numerator is 3. These are both divisible by 3, so we would divide by 3 over 3. We simplify to 1/12. So 5th graders, this is a good reminder when we're talking about fractions, which is the unit we just finished. I guess it's over a week ago now, but remember, oh, it's way over a week ago. Decimals was before. Yeesh. Okay. We always want to simplify. Anytime we're dealing with a fraction, if it can be simplified, we want to do that. Okay? Okay. So we've got all these fractions, right? 1/4 for small, and then medium, and then large, and then extra large. And so we could display this in what is called a pie chart, right? And so you see each portion of this broken up. So what do we notice? Think about the rules we talked about yesterday. Half, the straight line is showing us half of the pie chart. This right angle is showing us 1/4 of the pie chart. So this is consistent with our rule. And let's test out what we practiced before. Our total is 1/4 plus 1/6 plus 1/12 plus 1/12 plus 1/2, excuse me. So we're going to add these all together. And what should these equal based on the rule we talked about yesterday? When we add these all together, what should it equal? It should equal 1. That was the rule we said about fractions. So our common denominator here is going to be 12. So 1/4 equals 3/12. 1/6 equals 2/12. 1/12 is 1/12. That doesn't change. And 1/2 is 6/12. So if this works, when we add these all together, we should get 1, which, in case you're wondering, is 12/12, right? 12/12 will equal 1. So 3, 4, 5, 6 plus 6 is 12/12. So we're good. We're right. Okay. Remember, all, right? If you have 12 pieces of pizza and you eat 12 of them, that's all of the pizza. That's one whole pizza. So 12/12 is 1. Okay. So let's do some questions specifically about pie charts on our next page here. So we are told that there are 200 chairs in a warehouse. 80 of them are plastic chairs, 30 are metal, 40 are wicker, and the rest are wooden. The pie chart represents the number of chairs of each type. So we can see, right? Plastic chairs, 80. Metal chairs, 30. Wicker chairs, 40. Wooden chairs, we don't know. But if I were a betting person, I would imagine that we're going to be asked to figure that out. But here we go. 1A asks us, which type of chair is found in the greatest quantity? So looking at the picture, we could have a pretty good guess that plastic chairs is in the greatest quantity, right? That is the greatest part of the pie. That makes me a little uncomfortable though, because I think, well, what if someone drew a pie chart poorly, which by the way is absolutely something I would do. Not on purpose, but sometimes my recreations of things don't turn out as nice as I'd like. But actually part B is going to allow us to figure this out. So you might think, how am I supposed to figure out how many wooden chairs there are? When it comes to pie charts, the introductory information is really important. That first sentence in particular. There are 200 chairs in a warehouse. I'm not going to make you guys model draw this, but I want to just demonstrate, right? We're being told 80 for plastic, 40 for wicker, 30 for metal, and then we don't know how many wooden, but we do know from that first sentence that the total is 200. So again, you don't need to draw this unit bar, but that should help you to figure out, how do we find this out? We want to know what all of these are first, and then subtract that from 200. So 80 plus 40 plus 30, we add those together. So 8 plus 4 is 12, plus 3 is 15. So that tells us the known amount is 50. The total amount is 200. So how many wooden chairs are there? Yeah, 50 wooden chairs. Good. Okay, back to this fraction question, which we practiced on the previous page. What fraction of the chairs are plastic chairs? So remember, when we're talking about fractions, the denominator should always be the total amount. So what is the total amount? They gave that information to us. 200. So our denominator is 200. Our numerator is the number of chairs we're talking about. So what fraction of the chairs are plastic chairs? We've got 80. It's a fraction though, and we always need to ask ourselves, can this fraction be simplified? And the answer is it absolutely can. I like to remember, and maybe you guys remember, that if we see the same number of zeros in the numerator or in the denominator, we can cross those out, right? A 0 and a 0. It's like dividing them both by 10. So really what we're looking at is 8/20. This shares a common denominator of 4, so 8 divided by 4 is 2. 20 divided by 4 is 5, so 2/5 of the chairs are plastic chairs. Good. How many times as many plastic chairs as wicker chairs are there? Okay. So how many times as many plastic chairs as wicker chairs are there? So that's kind of a mouthful, but we want to think about how many wicker chairs are there. So there are 40 wicker chairs. How many plastic chairs are there? There are 80 plastic chairs. So the question is really, 80 is how many times 40? Or 40 times what equals 80? So what would be the answer to D? 80 is how many times 40? 2. 2 times. So this would be our answer to D. 2 times. Okay, so this gives you a little bit of an idea of how we might solve this problem. All right, with that in mind, we're going to go on to 132, which I have something written in my text, which is kind of a giveaway. Let's try to make it not be so obvious. Okay, into our textbook. Number 2, which tells us the pie chart represents the amount of money collected by various booths at a carnival. So the question is, what fraction, the first question is, what fraction of the total amount of money was collected by the games booths? So we have to look at our games booths and figure out what clue we have. And we have a clue that we talked about yesterday that builds on it. What do we notice about the games booth? Yeah, it's a right angle. We should remember that right angles are equal to what fraction? This is something that we were just told. It was something we just needed to know from our facts yesterday. 1/4 is the fraction that's equal to a right angle. Good. What was the total amount of money collected by various booths? Okay, this is a little bit tricky, but we can totally do it. Okay. Okay, so the clue or the hint that we need is I see a right angle here and a right angle here. If we see a right angle in both, what does that tell us? They're equal in chunks, which means they're equal in value. So that means that if this is 3,000, then this also is 3,000. Okay, I'm writing it dimly so I can erase it again. Okay, also, a quarter and a quarter makes up how much? If you have 1/4 of something and another quarter of something, what is that as a sum of a fraction? You could even think about it in like saying 1/4 plus 1/4 equals 2/4, which is equal to 1/2. So as we're thinking about how to solve B, I know I'm barely on the screen here, but we have these fourths, which are equal to half, or even 1/4 of it. If we broke our unit bar into fourths, and we know that 1/4 is 3,000. We're being told that 1/4 is equal to 3,000. And so the question then is, what is all of it? If we know 1/4 of it, we can figure out what all of it is. We can do that by multiplying 3,000 by what? 3,000 by 4, right? Because we have 4 of them. So we say 0, 0, 0, 12. So our answer to B is 12,000. 12,000, okay? How much money was collected by the music booths? So now we kind of have to think in terms of our total again. I'm going to make a little more room for us for C here. So again, we know our total because we just calculated it in B. We have 12,000. We also know the handicraft booth is 3,000. The games booth is 3,000. The food booths are 4,800. So what is left for music? I'm actually going to have you pause and try to solve this, and then come on back and see how you did. So step 1 is we want to figure out what these 3 are equal to. So you're going to add those all together to get your total for the parts that we know. So the parts we know, if you added correctly, would be 10,800. So now we have a whole, a part, and an unknown. So remember, in order to find this, we're going to subtract. And when you subtract, you should get 0, 0. This is actually bringing me, I've been helping my son with his math, and they are working on regrouping and subtraction for the first time. So it's bringing me back. Okay, to working with him, that is. When you do your subtraction, you should get an answer of 1,200 here, right? And we figure this out through this. And again, you don't have to draw a unit bar, but I'm doing it to really highlight to you that you know how to do this, that we have the tools necessary to do this. Okay, question 4 asks, what is the, we're actually going to skip question D because we've never actually talked about ratio. This is one of the challenges that we're running into with our reordering, which we do every year in 5th grade, some reordering, but we're doing even more now. So we'll skip the ratio question. So with that in mind, 5th graders, you're going to be doing your practice work and your homework in your workbooks today, okay? Your practice work is going to be pages 123 through 124, okay? 123 through 124, there's not going to be any questions about ratio, but there will be fraction questions here, okay? And then your homework is going to be 125 through 126, which has questions about percentages, but remember what we've been working on, right? If you know how to do a fraction, which is what we spent time doing today, then you also know how to do a percentage. So you're going to kind of build through those skills. Like for instance, I don't know, I'll just do this real quick. We figured out, for instance, that one of our fractions is 1/12. We did this work today in class. Remember, 1 divided by 12, this is the process we built on yesterday. So you do that division, right? In order to work through this. And 6, what is that going to be? 7, 8. Okay, 16 carry the 1, we get 96. 4, 40. This is probably a bad example because it's just going to keep on going. But we'll go 3, and it's going to be this 8.3 or 0.083 repeating. So then we go 1, 2, and get our decimal or our percentage of 8.3%. I'm standing right in the way. Okay, so if you're asked for percentages, it's the same process. You know how to find fractions, and then you're going to just convert that fraction to a percentage. Okay, you're going to submit pictures of pages 125 through 126. And yeah, again, this is kind of your checkpoint. I know this is like a jump, right? Pie charts are challenging, so I know it's going to be a little bit of a stretch, but you're going to make sure that if you're kind of now thinking, tricky, come see us during office hours and we can talk. Once you do the practice work, if you're feeling like, tricky, come see us during office hours. And then, of course, homework is kind of when you're feeling like ready to show what you've learned and mastered, okay? Keep those notes out and ready for you to reference as you go. They'll be very useful tools. Our textbook work also is going to be really helpful. So good luck. I know you can do it. I know it's challenging, but I totally know you can do it. You guys are very ready for it, okay? Come see us if you need help, though. Goodbye.